You already know what Ozempic is supposed to do. Make you less hungry, eat less, lose weight, a drug for your stomach and your appetite. But that's not the interesting part, because the real action isn't happening in your gut. It's happening in your brain, and that changes the whole story. So what is this drug actually doing up in your head? And why are scientists now testing it for things that have nothing to do with weight at all? Start with what the drug is copying. There's a hormone your gut releases when you eat, and it's called GLP-1. Back in the 1980s, researchers named Joel Habener, Daniel Drucker, and Jens Juul Holst worked out what it does. When food arrives, GLP-1 tells your pancreas to release insulin. It's part of how your body handles a meal. But natural GLP-1 has a flaw. It falls apart in minutes. On its own, it's useless as a medicine. Then, in 1996, scientists noticed something bigger. GLP-1 didn't just manage blood sugar. It also told the body, you're full, you can stop eating now. It was a society signal. So a team at a company called Novo Nordisk, led by Lotte Bjerre Knudsen, rebuilt it. They engineered a version that survives for days, not minutes. That rebuilt, long-lasting molecule is what you know as semaglutide. You know it as Ozempic and Wegovy. And the very first drug in this family traced back to the venom of a desert lizard. A story we've already told. Now here's the part most people miss. The receptors that GLP-1 plugs into are not only in your gut, they're in your brain. Some sit in the hypothalamus, the region that helps run hunger, but others sit somewhere far more interesting. Your reward system, the same circuitry that lights up for anything you crave. And that seems to change something people struggle to describe. Many people on these drugs report that the constant mental chatter about food just goes quiet. They've started calling it food noise, the background hum of thinking about the next snack, the next meal, the thing in the cupboard. For a lot of people, that hum drops to near silence. That's not a stomach effect, that's a brain effect. And in animal studies, scientists are starting to see how, when an animal eats purely for pleasure, its reward system releases a hit of dopamine. Dopamine is the brain's wanting signal, the nudge that says, again, more. Get that. Give the animal a GLP-1 drug, and that dopamine hit gets smaller. The tempting food becomes, in effect, less tempting. The drug seems to turn down the volume on reward itself, which leads to an obvious and slightly startling question. If it can quiet the craving for food, could it quiet other cravings too? Researchers are asking exactly that. There are early trials testing these drugs in people struggling with alcohol, and at least 2 clinical trials are underway for opioid addiction. It's the same molecule, aimed at the machinery of craving instead of your waistline. So let's be careful and honest here. A lot of the reward and addiction work is still in animals, or in very early human studies. Food noise is a real experience people describe, but it is not yet a fully proven mechanism. These drugs are not approved treatments for addiction, and a drug that reaches into the brain's reward system is a serious thing, with real side effects a doctor has to weigh. This is a science story, not medical advice, and there's no dosing, no sourcing, no how-to here, but step back. And the big idea is genuinely important. For years, we treated overeating as a problem of willpower, or just calories in and out. This hints at something different, that hunger, pleasure, and craving might share the same wiring, and that a single gut hormone somehow speaks to all of it. That's the thread worth pulling. Because if one signal links your stomach to your reward system, then appetite was never just about food. It's about how your brain decides what's worth wanting in the first place. And what happens when a drug gets a vote in that decision. Think about that for a second. A medicine that can gently turn down wanting itself. For food, that sounds like a miracle. For everything else wanting touches, it's a much bigger question. Where is the line between treating a craving and dimming a desire? Nobody has the full answer yet. The science is moving faster than the wisdom. But one thing is already clear. This was never really a weight loss story. It's a story about the brain's oldest engine, wanting. And what happens when we finally learn to steer it? A gut hormone, quietly wired into desire, a drug that stumbled onto the controls, and a question we're only starting to ask. That's the story we'll open up next time, one familiar molecule at a time. Thanks for watching Brainstorm Bob. If this made you think, hit subscribe for more. Curiosity, ideas, and real answers. See you in the next one.